Hello and welcome to Ott and Math. In this edition of Ott and Math, we're going to actually take this chapter and section in two sections. We're going to talk about slope and inclination in this first section, and then we'll talk about simple trig equations in the second section. So before we get into slope and inclination, I have a quick question for you. What is the value of 1 radian in degrees? So take a moment to think about that. All right, so the answer is approximately 57.3 degrees. And the reason why I put this in here is because I want for my students to understand that radians doesn't always have to have pi in it. And a radian measure is really some reference number of degrees. And it's approximately 57.3 degrees. So there are approximately 6.28 radians in a full circle. All right, so let's move on. Of course, as you recall from algebra and geometry, slope is going to be the change in y with respect to the change in x, or y over x. So I want you to put on your trig thinking caps now and think about how you can relate slope to some trig function. And of course, you're going to come up with the answer of tangent, because tangent and slope are brother and brother, so to speak. So tangent of an angle is the same thing as the y value over the x value, which is the slope. Before we get into using slope and tangent, I need to review equations of lines real quickly with you. The first is slope-intercept form. Y is equal to mx plus b, where m is the slope and b is the y component of the y-intercept. There's also point-slope form, which is y minus y1 is equal to the slope m times x minus x1, where y and x are just y and x, the variables, and x and y are the points on the line. And then, of course, there's standard form ax plus by is equal to c, which is not really a very useful form other than it looks nice to have the x's and y's on one side. All right, so you're going to use slope-intercept when we have a, the slope, and b, the y-intercept, of course. And then you can express your equations of lines in this form unless I tell you otherwise. So in general, even if you use point-slope form, I want you to rewrite the equation in slope-intercept form. So we have 2 points, 0, 4, and negative 3, 0. We can find out the slope at 4 over 3, and we have the y-intercept at 0, 4. So y is equal to mx plus b. Y is equal to plus 4/3 x plus 4 would be the equation for this line. In point-slope form, we can use point-slope form, and point-slope form is more versatile, in my opinion, than slope-intercept form, and definitely much more versatile than standard form. So we're going to use that when we have either 2 points or a point in the slope. And in this case, the point can be or not be the y-intercept. So in this case, we have a point, which is 1, 5, a slope, which is negative 3. And then we're going to write our equation y. Of course, y just stays as y. Minus 5, or y1, is equal to negative 3, the slope, times x minus 1, which is x1. And then rewriting that in slope-intercept form, I'm going to add 5 to both sides, distribute the negative 3, and then simplify, end up with y is equal to negative 3x plus 8. Okay, so the inclination of any line is the angle whose initial ray is the positive x-axis and has a value between 0 and 180, inclusive of 0, but not 180. So you have to remember that the angle measure has to be between 0 and 180 degrees. So again, inclination is an angle measure whose initial ray is the positive x-axis and a value between 0 and 180 degrees. All right, so in this case, we can use the inclination to find the slope, and you do that simply by taking the tangent, and you can do this in your calculators, tangent of 53.13 degrees, and you should end up with a slope of 1.33. So this just goes to show you that inclination and slope are related, and you can determine that relationship involving the trig function of tangent. All right, so another way to look at this is I have a slope of 7/2. What's the angle of inclination? Right, so now we're moving in the opposite direction. So now I'm going to take the inverse tangent of the slope, which is 7 over 2. And if you're in degrees, you'll come out with an inclination of 74.05 degrees. All right, so now I want you to find the inclination if the slope is 5/7, 9/2, and negative 4/3. You can use your calculator. I'm going to pause for a second. You can do your work, and then let's come back. All right, so in order to find these values, you're going to take the inverse tangent of the different slopes, as I've indicated here. And then you're going to come up with the answers in degrees: 35.5 degrees, 77.5 degrees, and 126.9 degrees. Now, I believe in your calculator, if you take the tangent of negative 4/3, you'll end up with negative 53.1. But remember that inclination has to be a value between 0 and 180 degrees. So now you have to find out what that angle measure is based on an angle measure of 53.1 degrees. So the other measure that's between 0 and 180 degrees, that is also equal to negative tangent of negative 53.1 is also 126.9. All right, now we're going to go in the other direction. We're going to find the slope given the inclination. So this is pretty straightforward. You're just going to take the tangent of these different degree measures. So I'm going to pause here, and you can get your answers. All right, so the process would be taking the tangent of 170, 55 degrees, and 95 degrees. And you should end up with negative 0.18 as a slope for 170 degrees, 1.43 for the slope of 55 degrees, and 11.43 for the slope of 95 degrees. All right, so now we're going to use this to create an equation for a line. So let's start with, I have a slope of a line with an inclination of 75 degrees, and we can find that slope, of course, by taking tangent of 75 degrees, and we're going to end up with a slope as indicated of 3.73. All right, so now we're going to use that, and we're going to create an equation for a line. And if you recall from Pointslope Form, what we need is the slope and a point. So I'm giving you the point at 3, 4, and we have a slope 3.73, or based on an inclination of 75 degrees. And now I want you to pause and write the equation for this line. All right, so now we're going to use a point-slope form. Y minus 4 is equal to the slope times x minus 3. And then distributing 3.73 and adding 4 to both sides, you end up with y is equal to 3.73x minus 7.19, which is in slope-intercept form. All right, so now I want you to find the equation of the given lines based on the criteria below. So I'm going to pause here and then come back. All right, so in this case, I have an inclination of 45 degrees. Y-intercept is 0.6. I find out by taking the tangent of 45 degrees that my slope is 1. I set the equation up in point-slope form. Y minus 6 is equal to 1 times x minus 0, rewriting as y is equal to x plus 6. Inclination of 132 degrees. I figure out tangent of 132 is negative 1.1. I write this in point-slope form. Y minus 7 is equal to the slope negative 1.1, or the tangent of 132 degrees, times x minus a minus 3, or x plus 3, which is rewritten as y is equal to 1.1x minus 3.3, plus the 7 that was added from the left-hand side, and then simplifying y is equal to negative 1.1x plus 3.7. All right, lastly, I want to find the inclination of the line perpendicular to 4x plus 3y is equal to 12. So the first thing we need to do is we need to find the slope of the line 4x plus 3y is equal to 12. And then we need to determine the slope of the line that's perpendicular to this line. And then we need to find the inclination. All right, so we're going to rewrite, this is in standard form. We're going to rewrite this in slope-intercept form to find the slope. So 3y is equal to negative 4x plus 12. I subtracted 4x from both sides. Now I'm going to divide by 3. Y is equal to negative 4/3 x plus 4. And I can see from this that my slope for the original line is negative 4/3. I know that the slope of the line that's perpendicular to this line is going to be the opposite reciprocal. So opposite in sign, reciprocal in value. So my slope of the line that's perpendicular to this line is 3/4. Now I'm going to take the inverse tangent of 3/4 to find my inclination. Inclination of this angle is 36.9 degrees. right, so basically we can say that the slope is equal to the tangent of the inclination. And that's what I wanted you to get from this video. I hope you had a great time listening to it and got a couple things out of it. Join us for the second half when we talk about solving simple trig equations in the next edition of Oughton Math.